It's now time to get going with some more ABAP. And we're going to focus on working with other data types that we haven't yet come across. So far, we've looked at using numeric fields for performing calculations, and we have taken a look at character strings and the different type of character manipulation that we can do with the various inbuilt character string ABAP statements. But now let's move on and take a look at date and time fields. So before we start, let's go into the ABAP editor and get ourselves a brand new program to start with. So we will execute transaction SE38. That's the previous program that we used when looking at character strings. So let's copy this. And we'll call this Z other data types. Now it's been copied, we'll click the change button. I'll just update the comments. And let's get rid of lots of this code. Date and time fields are not defined as numeric data types, but are instead defined as character data types. They are really just character strings that can be used in calculations. And this is made possible by the inbuilt automatic data type conversions that we have already discussed in a previous module. And just like any other data type, we use the data statement to declare these date and time fields. So if we focus first on the date field, we will use a data type of D, which is always defined as 8 characters, with the first 4 characters representing the year, the next 2 the month, and the next 2 the day. So we would write it, we give it a name, my date, type D. That's it, pretty simple. One thing to note, when we don't define an initial value, the system automatically assigns zeros to the field. When you do want to assign an initial value, just like any other field, we use the value addition. So 2012 0101. And don't forget, like any other field, we are not just limited to using the type statement. If we already know a field defined as a date type and we want to reference that field, we can use the like statement. So what's this one? SYDatum? Well, this is a system variable that always holds the value of the system's date. So the myDate2 field, we're defining it the same as the SYDatum field. Now let's move on to time fields. As you know, I don't like excessive typing. So time fields are very similar to date fields, but instead of being 8 characters long, they are 6 characters. And they have the format of hour, minute, second. And just as with the date field, the initial value is always zeros. To define the time type, instead of D, we use T. So we can say 11 hours, 10 minutes, 5 seconds as the value. And the same when we want to reference an existing field. We will use the system time field, which is SY-UZEIT. So let's now output some of these date and time type fields to the screen so we can see the output format. So we'll just make a comment. And then we'll use the write statement with the chain command. So we'll output the first date, and on a brand new line, date number 2, and my time on a brand new line, and my time 2. And then we'll finish it with an underline statement. There we go. Run a quick check. Oops, a little problem. Let's go fix that. Oh, silly me. And the U line is a command all on its own. There we go. That's better. We'll activate and then test. So the output is showing us 4 fields. The first one contained the value of the date that we keyed in the data declaration part. And we can see it's the 1st of January 2012. But remember how we keyed it in a reverse order? We did 2012-0101. Well, the write statement applies its own formatting, and as we discussed in one of the previous modules, you can format the output as you like with the write statement. The second field is a date field as well, but we didn't define any value to that date field, so the system has output the initial value, and it's used the automatic formatting by inserting periods between the day, month and year. And it's using the formatting that's associated with our user logon. The third and fourth, very similar again. We can see they are both time fields. The first one has a value and the second one doesn't. So now let's move on and see how we can use the date and time fields in calculations. Now that we've seen how to declare date and time fields, let's perform some example calculations with them to show how they can be used. Now you probably know that using date and time fields within calculations is common practice in programming business systems, because you often have to determine differences between 2 dates, generating dates such as invoice dates, delivery dates, salary payment dates and so on. So let's go through some examples of how we can use dates within calculations to both generate new dates and find out the difference between dates. So first of all, let's tidy up this program a little bit. Okay, so what we're going to do is define an employee date. Still tidying up. Okay, so we'll use the data statement. And we'll define a start date for an employee. Tell you what, let's not assign a value straight away, we'll do that in the code. So there we have the data statement. and we'll assign a value to the variable. With a start date of May the 15th, 2009. And remember, date fields are character fields, so we have to enclose the date in single quotes. Then let's define another field. And we'll call this one today's date. And for today's date, we're going to assign the system variable to pick up the date of the system right now. We will then add a calculation to determine the length of service for this employee. So we will create a new variable called LOS. Together with a simple calculation, and I must remember to add in the length of service. We'll make it an integer. In the last action, we will just write out the length of service. Okay, it looks pretty straightforward. Let's just execute the code. So as we can see, the length of service is 1,160 days. So the calculation has given us the length of service in the number of days. Let's do another example where we want to add 20 days to today's date. So it's quite simple. Let's just copy some code. We will use the same today's date variable and assign it to the system date again. We'll create a new variable called days count, and we'll assign it a value of 20. Don't know why I'm using quotes. It's going to be an integer. And we'll create a new variable called future date. Oops. Which will take the calculation of today's date plus the day count variable, which will contain the value of 20. And then we can write out the future date. Let's go add the data variables. Have I made a spelling mistake? Oh dear, am I going blind? There we go. Oh dear, look at this. I can't type. Do apologise for this. There we go, that's better. So now we should have 20 days added to today's date and see the output. Here we go. So 20 days on from today will be the 7th of August 2012. If you remember in a previous module, we worked with subfields. Well, all the same logic applies when working with subfields that are based on date and time fields. So let's create an example to change one of our date fields to represent the 20th of the current month. So again, I'll copy some code. We will leave today's date equaling the system date. And what we will do is make the day subfield of our date equal to 20. Now currently it's the 18th of July, so the system date would be the 18th. We can update the last two characters of our date field with the value of 20. What I'll do, just to save on a tiny piece of processing, is include the value 20 in quotes to make it represent a string rather than an integer. And all we need to do is write out today's date. Oops, my apologies. Oops, a tiny error. Let me just correct that. There we go. And we'll test the program. And as you can see, the output now says the 20th of July, 2012. For completeness, let's just output the system date as well. So the system date is the 18th of July, then our output date is the 20th. Now in our last example, in this section, we will show how we can determine the last day of the previous month. So again, let's be super lazy, copy and paste. We'll leave today's date. And what we're going to do is set the day to the first. Then we're going to show how we can subtract a value from today's date. And we'll subtract the value of 1. So today's the 18th of July. So then this row of code here will make our date equal the 1st of July. And then when we take the value of 1 away, which means 1 day, we should end up with the last day of June. Let's stick an underline in the last section. Pretty it up, check it, and then test. And there we can see we found the last day of the previous month. Let's move on to working with time fields. Just like using calculations with date fields, we can also do the same with time fields. All of the same principles apply. So let's get straight onto it and look at some examples. In these examples, we'll have a look at the fictitious employee clocking in and clocking out times. So first of all, we're going to declare the two times, clock in and clock out. So back up to our data section. Let's create a new little block. Just make it a little easier to read. So let's declare a clock in. And a clock out time. And while we're at it, let's declare some more. Let's do a seconds. So this is going to hold the difference in time in seconds. May help if I spell it right. As you might guess, we'll do a minutes and an hours. Line it up just so it looks a bit easier to read, and we'll do the same over here. A bit easier on the eye. Now go down to the code. And let's start filling some of these fields with values. So our clock in time, let's equal 7:30. And we'll equal 4 o'clock in the afternoon for the clock out. And then let's work out the difference in seconds. Let's see if I got everything correct. Almost missed off the S. There we go. And finally, let's write out. We'll make it a bit more descriptive, eh? There we go, that should do it. So we're going to write out a bit of text to say the clock in time was, and then the clock in, the clock out time was, then the clock out, and then shows the difference in seconds. I do apologise, I don't know what I'm doing here. I don't know why I've made the seconds diff equal this. This should be a calculation. So let's amend that before we run it. So this is clock out minus clock in. There we go. So this should be 1600 hours minus 0730, giving us the difference in seconds. Pretty it up. See if I made any mistakes. There's a bonus. Now we'll test it. So there we can see clock in time, clock out, and the difference is 30,600 seconds. Now, is that correct? Let's have a look. So we have 8 hours and 30 minutes. So 8 times 60 plus 30 times 60 is 30,600 seconds. Let's now continue and work out the minutes difference and the hours difference. So it's a simple calculation for the minutes. Remember, you must save your precious fingers, so copy and paste as much as you can. All we need to do is reference our seconds. And divide by 60. So now we should see 33,600 seconds divided by 60, giving us, I can't remember what that calculation was, 510 was it? Something like that. Then we'll write out the difference in minutes this time. And while we're at it, let's do the hours calculation. And why not pretty it all up? Okay, pretty printer. We'll do a check to see if I made any mistakes. And it looks like I did. So what did I call hours diff? Okay, I made a mistake up here by the looks of things. There we go, just one S. Okay, everything is good this time. Now let's test. Oh, no doubt you've seen the mistake. Here we want to output the minutes, not the seconds. I guess this is what happens when you copy and paste too much. Okay. Test it out this time. There we go. So seconds, 30,600, minutes, 510, and hours, 9. And I see I even made the spelling mistake there too. So, if we had 510 minutes difference, then the hours wasn't 9 exactly. But can you see why we were given 9 as the answer? Hopefully you recognise that the hours diff was an integer. If we'd have made it a packed decimal, we would have got a decimal result, giving us 8.5 hours difference. But because it was an integer, it was rounded up to 9. You want to check it out? Let's change that integer to a decimal. So what we need to do is move to the data declaration part, and where we have an integer, let's change it to a packed decimal. And remember, we need to specify how many decimal places we want. We'll put 2. Everything looks good. We'll activate it and then test it out. And as you can see, the results now is 8.5 hours. We will now focus on quantity and currency fields. And in ABAP, these fields are treated just like pack number fields. And as such, you need to declare your currency field as a pack number. When you do this, always bear in mind how many decimal places you want, just as we did with the hours diff field in the previous exercise. Now in a real-life scenario, the number of decimal places has a great impact on the accuracy of your calculations in your program. And quite often your program will use a much higher number of decimal places in your calculations than those actually shown on list reports. Now quite often in your programs, you want to create your own variables for quantity and currency fields, but you'll find it's a lot better to associate your fields with the data type of fields of a table in the ABAP dictionary. And the reason why I say this is because the ABAP dictionary already has the field length and number of decimal places already defined for individual fields. Take our salary field in our employees table. We define 2 decimal places. So if we declare a currency field in our program to match that of salary in our employees table, we would normally have to refer back to the table itself, find out how many decimal places there were, and then define that manually in our ABAP program. Now there could be a scenario where the number of decimal places in the table would change, but our program, because we define it by ourselves using a type P for packed decimal, we could then have an incorrect number of decimal places in our program if the field is supposed to always reference the field in the table. So my preference is to always use the like statement. So when declaring my packed decimal fields for currencies and quantities, I'll always reference the table whose data I'm going to be reading into my variable or passing data from my variable to. So let's take a look at how we would normally define a currency field in our program. Here we go, so you can see I've used the data statement, created a field called my salary, then I'm using the like statement to reference our Z employees 2 table and the specific field salary. Now because we link our field in our program with the field in the ABAP dictionary, the system must always make sure the data types are kept in sync. And there are 2 aspects to this process: the number of decimal places and the associated currency or quantity keys. So as we saw when we set up the salary field in the ABAP dictionary, a currency field corresponds to an amount field of type DEC, decimal. Let's have a look. So let's pop over to the ABAP dictionary, have a look at our table, and here we have the salary field, and we can see it's currency type 9. If we double click on the data element, we can see that the domain is currency 9. We'll double click that, and then let's do a drop down in the data type here. And it gives us a hint that the currency field is stored as a decimal. And something else we can do if we just double click on the currency type here, we get a screen that shows us the internal format for our ABAP programs. It uses the ABAP type P for packed decimal. And don't forget, when we set this salary field up, we had to reference a currency key field, which we declared as eCurrency. So these 2 fields always go hand in hand. A currency field always references the currency key, which is of type CUKY, which in ABAP world have a data type of character and have a fixed length of 5, which we can see here. So what this all boils down to is when you are declaring your fields in ABAP, reference the fields that they associate with in your table, and always bear in mind that every currency field We'll have a currency key that more often than not you have to take into account when outputting results to a report. And then for quantity fields, the same sort of thing applies, but instead of having a data type of currency, quantity fields, let's see if we can show this, have a data type of QUAN. Here we go. And instead of having a currency key, they will have a unit associated with them. So let's step out of this and go back to our program. Let's go on and create an example to calculate an employee's tax and net pay amount. So here in the data declaration section of the program, I've already defined my salary. So what I'm going to do is also declare a tax amount. And the tax amount is going to be a very similar field to salary in that it's a currency with 2 decimal places. So I'll just reference the same field in our table. Then let's declare a net pay. Same again, we'll reference the same field. And we'll declare a tax percentage. And pretty it up. Help if I spelled decimals correctly. So now we have our fields defined. Let's go to the bottom of this program and start coding. And what we're going to do is select records from our table, calculate the tax and net pay, and then output the results to a report. So to save some time, so you don't have to watch me make spelling mistakes, I've already coded this out. I'll just paste it into the program. And then also, we need one more statement at the top. Then I'll explain it. Okay, so because we're going to read data from a database table using a select statement, we're going to declare the table at the top of our program, zEmployees2. Then we'll go back down to the bottom, and I've written a select statement from the table. Then we're going to write out the employee's surname, their salary, and the currency. Let me bring this full stop up. The next thing, we're going to calculate the tax amount. And that's by taking the tax percentage multiplied by the employee's salary. So then the net pay amount is the salary minus the tax amount. Then we're going to output the results onto the screen. But there's one thing we haven't done, and I believe that's tax percentage. Actually worked out what the percentage is. Or should I say, we haven't declared what the tax percentage is. So in the data declaration part, I'll tell you what, let's do it down below in the code. So we're going to say our tax percentage is equal to 20 to represent 20%. Oops, there we go. Okay, Now, just before we run the program, let's have a quick peek at the data. Now we have 6 records, but as you can see, only 3 have salary information and currency. So let's change that. Let's edit these records and key in some values. And what should we choose for the last one? Fiji dollars. Okay, let's step back, and now we can see these records have values in the salary and currency field. All looks good. So let's close that window and we'll test the report. So here we have the first record, Smith. The salary is 1111. Then we have the currency code. Then we output the tax amount and the tax currency and the net pay amount and net pay currency. So the tax amount should be 20% of 1111, and that looks about right. And that should be taken off the salary to give us the net pay. Just to make it a little bit tidier, let's include some descriptive text. Run it again, and there we can see. Oh, let's tidy it up a bit more. I am picky. Let's skip a line. There we go. So Smith, the salary, currency, the tax amount is this, and the net amount is this. All with the currencies in there. And that wraps up this module.